In industrial equipment, there is one component we can never avoid: the reducer. We took an in-depth look at servo motors in our previous video. Today, let's learn about the perfect partner of a servo motor, the reducer. What is a reducer? Simply put, it reduces speed and increases torque. It lowers the rotating speed of the servo motor through its mechanical structure, while greatly boosting torque to deliver stable and powerful power for industrial equipment. You may wonder, if we just need higher torque, why not simply use a higher power servo motor? Why add an extra component that may even cause power loss? The core reason behind all equipment technical upgrades comes down to cost. A low-power servo motor may only cost a few $100s, while a 2-3 kilowatt servo motor can cost more than 10 times that price, and also comes with a much larger size. By sacrificing a little speed, a regular servo motor paired with a reducer saves equipment space, cuts manufacturing costs, and ensures working efficiency. That's why the matching combination of servo motor and reducer remains the most cost-effective and optimal solution by far. But how exactly does a reducer accomplish its work? The secret lies in its internal transmission mechanism. Simply put, a small gear drives a large gear. When the small gear rotates to full turns, the large gear only turns once. This reduces the motor speed, and meanwhile, the rotation of the large gear brings a significant increase in torque. Now that we understand the basic working principle, let's take a look at the most popular types of reducers on the market. First, let's start with the most widely used planetary reducer. As its name suggests, it consists of one central sun gear and 3 planet gears. The rotation of the planet gears outputs power through the planet carrier. Planet gears are divided into spur gear and helical gear types. Helical gears have a larger meshing contact area. Under the same input shaft conditions from the motor, they can transmit much higher torque, generally 20% to 30% higher than spur gears. You may wonder why there are exactly 3 planet gears. The key reason is the stability of the triangular structure. It ensures even force distribution during operation, reducing failure rates and gear wear. Although planetary reducers seem nearly perfect, they still have meshing backlash between gears, which makes them unsuitable for ultra-high precision applications. Next, let's talk about the harmonic reducer, which raises the ceiling of precision performance. A harmonic reducer is mainly composed of a wave generator, circular spline, and flex spline. The wave generator is elliptical and fits inside the flex spline. When it rotates, it deforms the flex spline into an elliptical shape. The teeth of the flex spline mesh with the teeth of the circular spline. Normally, the circular spline has 2 more teeth than the flex spline. For every full rotation of the circular spline, the flex spline lags behind by 2 teeth, realizing speed reduction and torque amplification. You may ask, with flexible material involved, how does it achieve such high precision? First, the flex spline is made of wear-resistant and stable chromium alloy steel. Second, the deformation of the flex spline is always controlled within a safe range, with no permanent deformation occurring. Its pursuit of high precision means it cannot excel in torque output. Therefore, harmonic reducers are compact in size and mostly used in semiconductors, optical instruments, and similar high-precision fields. The last type is the RV reducer. Simply put, it combines planetary gears with cycloidal pinwheel transmission, achieving torque boost through 2-stage speed reduction. The first stage adopts a planetary gear structure, and the second stage uses a cycloidal pinwheel structure. This structural design delivers excellent overload capacity for equipment, while featuring the most complex manufacturing process and higher cost. Now that we've covered the main types of reducers and their working principles, you may have a question. When buying a laser cutting machine, salespeople often mention flange reducers or shaft-mounted reducers. Let's explain this separately. A flange is defined as a round, perforated mounting and connecting disc used for fixing, coupling, and sealing. A flange reducer is simply a reducer installed by means of a flange connection. This mounting method delivers better torque performance than the shaft-mounted type, though it costs more. For this reason, flange reducers are highly recommended for laser cutting machines. Now that we have a general understanding of modern reducers, let's take a look at how reducers evolved throughout history. The history of reducers records the evolution of mechanical transmission technology from rough to precise and from single form to diversified applications. 1. Embryonic and initial stage BC 1700 AD. This was the primitive exploration phase of gear transmission. Wooden and bronze gear sets appeared in ancient Greece and ancient China, applied to water wheels, south-pointing chariots, and other facilities to realize basic speed reduction and force amplification. In the Middle Ages, small precision gear trains were used in clocks and astronomical instruments, accumulating rich experience in transmission technology, though independent reducer products had not yet taken shape. 2. Birth during the Industrial Revolution 1700–1900. Reducers officially became independent industrial components. The popularization of steam engines drove the research and development of enclosed gear transmission, while the maturity of involute gear theory promoted standardized processing. In 1880, the worm gear reducer was introduced, becoming the first general-purpose industrial reducer. In 1890, the theoretical system of planetary gear transmission was finalized. By 1900, enclosed housings and oil bath lubrication were widely adopted, enabling standardized mass production. 3. Structural innovation and maturity stage 1900–1950. Continuous breakthroughs were made in transmission structures. In 1926, the principle of cycloidal pinwheel transmission was invented, perfectly suited for heavy load working conditions. In the 1930s, helical gear reducers gained popularity, reducing noise and improving transmission efficiency. In the 1940s, the flange mounting structure emerged, laying the foundation for direct connection with motors. During World War II, military demands accelerated the upgrading of reducers toward higher precision and rigidity. 4. Start of precision servo era 1950–1990, a critical transition phase toward high precision. In 1955, the harmonic reducer was invented, featuring miniaturization and zero backlash, and was first applied in aerospace and military industries. From the 1960s to 1970s, planetary and cycloidal reducers achieved mass production. In 1980, the RV reducer was launched, becoming the core joint component of industrial robots. In the 1980s, servo-specific planetary reducers matured, matched with servo motors, and widely adopted in high-end manufacturing. 5. Digital popularization stage 1990–2010. Great upgrades took place in precision and standardization. With the widespread use of DSP numerical control and high-precision gear grinding technology, reducer precision reached the arc-minute level. European, American, and Japanese brands dominated the high-end market, forming a market pattern of high-end precision products and low-end general models. General-purpose reducers developed toward low-cost and large-scale production. 6. Intelligent upgrading stage 2010–present. Moving toward intelligent collaboration. Reducers have been upgraded to feature miniaturization, low backlash, and high torque density. Integrated sensor components enable condition monitoring and early fault warning. Continuous optimization of materials and manufacturing processes enables deep integration with servo motors and CNC systems, making reducers a core transmission component of intelligent manufacturing. Small gears drive big industry. Evolving from simple gear sets of the Industrial Revolution into core components of modern precision intelligent manufacturing, reducers have always pursued the goals of higher precision, greater torque, more compact size, and higher reliability over the past century. In high-end equipment such as laser cutting machines and robotic welding arms, the perfect combination of reducers and servo motors serves as the core guarantee for achieving high precision, high efficiency, and high stability. That's all for today's content. Welcome to like, comment, subscribe, and follow me. I will keep updating industry expertise and persist in sharing professional knowledge, helping more people understand industrial equipment. Zoryor, your reliable partner.